clean code, it's been over a decade now. The topic has been beaten top to bottom, right? I mean, there are a lot of blogs, YouTube videos, courses out there that will explain all these things. But still, after a decade, in 2022, we are still talking about how clean code is making it possible to evolve. Not only evolve, but also go at a faster rate, right? So we are here to talk about a journey with our clients, and how clean code made us move faster, right? There is always this concern, like in today's world where everybody wants to go to the market faster, they want to beat the competition, they want to get the market share. There's always the need to go fast, right? And also there is a concern, right? Hey, is clean code going to slow me down, right? Is it going to stop me from going to production within a month, right? So these talks still exist today, and it more exists today because of how things are, right? So here we are here to share a journey which proves it otherwise, and which talks about like what did we do actually to ensure that we can still do clean code and then go faster, right? So before that, what do you think of this doctor? Would you, if you or your family members are unwell, would you go to this doctor? So this doctor charges very less, does not sterilize instruments to reduce cost, passes the benefit to people. Would you go to him? Okay. Would you board this flight? Okay. So the routine services are skipped. Pilots are not trained to reduce cost because training is expensive. This is the cheapest airline. Would you board this flight? No, not even before MH XYZ, right? We will not board this flight. The same goes with code as well, right? So will you hire this developer? Skips testing, writes poorly designed code, difficult to navigate and onboard new developers, but produces buggy working code. Well, I'll leave it to the audience to figure out what to do, right? But the backstory is, if you look at it, right, so always there is this mindset, always there is this thought process that says, hey, I want to go fast, clean code is slowing me down, right? Writing test is slowing me down. So always when we think of this moving fast, we always look into two things, the dollar and the time, right? And the quality aspect of it goes under the carpet most of the times, right? So if you look at it, why this happens, right? So there's this Venn diagram here that says it's between quality, cost, and time. So what it says is like if you want to move fast with good quality, it's going to be expensive for you, right? It says if you want to move fast, but if you want at a cheaper price, you're going to pay for the bad quality, right? And if you want good quality, but at a cheaper cost, you're going to go slow, right? Can we hit the sweet spot? Can we hit the sweet spot where I can go fast with good quality with cheap price? Well, it's a question mark, right? So we're not saying that we can't do that, but we are saying that over time, following some certain practices and routines, we can eventually move faster. So I would like to tell an analogy on this, right? Think of you doing a job of going out and buying something from a store, right? Yes, of course you can go walking, go get it from the store. And if you have to do this day in and day out and again, you can still do that. You can go walk and then go to the store, get it, right? But what if you are learning a bicycle, right? Learning to drive a bicycle, right? Initially it is going to be slower because you're learning, you might not go at that speed, but eventually it will help you to go faster and it will make you more efficient, right? That's exactly what we are talking here. So if you look at this graph, this is between time and functionality, right? So if you look at this breaking point, you would see that somebody who is going fast will be faster, will be like looking like he's going faster, but eventually over time as the code grows, the complexity also grows, right? You would have heard a lot of stories from developers, like they'll say, hey, you know what, I want to make this change, but I need to touch 10 places, right? That is amplification, change amplification. Like you also would have heard stories like, I don't know what this method is doing. I want to talk to this developer who has written this code, right? And it is like, it is going into another class, it is going to another class, lot of cognitive load, right? Then there is unknown. So only the developer who wrote that code knows, nobody else knows, right? There is also a funny comment I read. I wrote this code, I know this, apart from me only God knows, right? So these things exist even today, right? And code is vulnerable for this kind of things, right? As it grows, higher chances that it's going to get complex. So we'll talk about what process we put in place, what routines we follow to control complexity, right? So we're not saying that hey, if you follow this, there will be zero complexity. No, we will have to hit complexity, right? But how do we mitigate it is what we're going to talk about. But before this, I want to take you through two lenses, right? A lens of an executive. If you look at the lens of an executive, what he wants from his team, right? He wants to build a team, like he wants to onboard new developers with ease. He doesn't want any dependency deadlock, right? He doesn't want, okay, that is one rockstar developer in your team. If he quits, nobody knows the code, right? We don't want that. Like easy to rotate people across initiatives, right? And reliable and predictable outcomes, right? Now we are all remote, so it has to be very remote friendly. It has to be effective. And it has to be a federated governance, right? No longer we are into a centralized governance rule, right? We are all federated ownership. This is what an executive wants, right? So if you look at from the lens of sorry, if you look at the lens of a developer, so I mean at the heart, right? We want to code, we want to code, no meetings. Of course, we can't escape in today's world. But we want to we want less meetings, we want common ways of working, we want quality practices, we want routines, we want a aspiral growth path, and we want connectedness with what business outcomes are. So basically both these lenses, if you see, right, they're all talking, it all boils down to one thing, which is code, right? I think today in XConf you would have, there's a lot of technologies been spoken by various people. There was Rust, there was Python, there was everything was there, right? But at the core, it's code, right? Whatever language, whatever framework, it's code, right? And it all boils down to how we are going to enable to move ourselves faster. In order to enable ourselves faster, we'll have to come up with a modular, maintainable, and evolvable code, right? That is what is the key, right? And we will talk about a journey. I'll hand over to Arif to speak about what we did, what we built, and we'll talk through other practices.
Hello everyone, hope I am audible. Alright, beginning with a backstory, basically what was a business need? What was the thing which was asked from a business? Basically what is something which we wanted to build? So talking about the complexity of our application, basically our client came to us asking that, hey, we have an application in hand, but actually this application is not sufficient enough to handle with the number of users which are increasing day by day on our application, and we want really to build something next generation application which can evolve and scale as per the need. And of course this application is something which is going to use a lot of transactions. You see, there's going to be a million of transactions happening on this application. There's going to be a lot of status update. So it was mostly a data driven application in which a lot of complex things were involved. So while developing this, we actually went ahead and were able to develop this application. We are actually live in the production around for 6 months. Everything is working fine. Customers are using this application very well. There is no performance issue, there is no scalability issue, and turns out that the client came back to us asking that, hey, this application is actually performing really well, and this is something which you want to utilize in our on-premise system as well. Now it may be very obvious that we can say, okay, you want to use this application on your on-premise system, go ahead, deploy this application on your system. But the thing is, the challenge here is it was not that simple, because their on-premise systems were located in such areas of the country where there was an internet connectivity issue, which means we cannot go on the cloud route. And the application which we built was purely on cloud. We were using cloud landscape in order to scale everything. We were using NoSQL database in order to update, in order to have more scalability point of view. But the on-premise system which we are talking about here basically had a lot of constants such as networking issue, and similarly it had resource constant as well, which means that they cannot afford to install any additional database such as NoSQL. They were only using SQL database and they wanted to go ahead with that only. Now that becomes our next challenge, that we have to somehow change this application into a dual profile app, which is our theme basically, that the same application depending upon the environment can run with two different types of database. One, obviously the NoSQL, which is already working, but should be able to work in a SQL manner as well. Now before jumping into how we actually did it, let's try to understand what do we mean by clean code here. So there are a lot of principles which we follow in clean code, and there's a lot of practices which are there which we can follow. But starting with, we can talk about composable pieces. Now what do we mean by composable pieces? I hope everyone here would have played Lego game. It's like this tiny small bricks using which we can create or made any type of architecture which we want to create. But the beauty of these small bricks is basically that tomorrow if you want to create a completely new design, it's just about pulling these small bricks apart and putting them back into a new architecture. So that's about reusability. You are able to reuse these small bricks into creating something different. Same thing is something which is applicable in software world also. When you write a piece of code, it should be written in such a way that tomorrow, for whatever reason, let's say your requirement changes, you have to create something else. You should be able to incorporate that new functionality without making a lot of change. Your code should be written in such a way that most of the functionalities you can reuse, and it's like very minimal work you should be doing. Talking about the next thing, it's like more of like single responsibility principle. So whenever you are writing any piece of code, ideally it is intended that it should be doing only one thing at a time. For example, let's say you write a function. If that function is doing a lot of things, then of course you are increasing your complexity. That means over time it will become very hard to manage that function. It will keep on increasing, and any new developer comes, they will not be able to understand, and it will be like, okay, who wrote this code? Let's go to that developer only to find out what this code is doing. So yeah, and the same thing is applicable even for the developer life also. In this fast growing time, we always try to keep ourselves occupied with multiple things, but then that of course causes issues. So instead of getting yourself occupied with multiple things, if we focus on only one job at a time, finish it and then jump to the another one, that will increase our productivity as well as the code quality. And of course, no surprise is always deterministic, which means, what do I mean by that? This is basically a code should be predictable. Now what do I mean by predictable? So when you write a code, basically as a developer we have to write a lot of code, and it's not just about writing code, we have to read also a lot of code. Most of the time it's not just about writing, you have to reuse whatever is already written. Now how you will reuse? You will be able to reuse those code only when you are able to understand. So by predictability we mean that the code should be in a manner that you should be able to understand just by looking at it. While on the other hand, if it is like too much complex, then of course it will be unambiguous and would be hard to understand. And of course in this case a lot of factors also come into picture. For example, mutability. Let's say you pass an object to a function, let's say, and that function is actually internally changing that object. Now there is no way for a developer to know, who has not written that code, that how on earth this object got changed. So we should focus more on the immutability part, that we should not be mutating the states and instead keep the state constant, or rather return a new object itself instead of manipulating it. Similarly, if you have a tests, let's say if you are writing any piece of code and if you have a test associated with that, then of course that's going to fail, and since it will fail, you will have an easy feedback or maybe early feedback that okay, you have made a change and now you have a test associated with that proving that something has changed and the test is accordingly failing.
You can see. You can change it. Yeah. So the next concept is like mirror domains and real world keywords. So if you are building like a banking application or you are building a e-com application, it's better to model and talk in terms of those domain terminologies, right? So things like checking out, right, checkout, adding to cart, or creating accounts like your KYCs, right? So use as much as real world and domains as possible for you to following the domain driven design, right? So no clever and ingenious hacks. So this is more of a case of if loops, right? Like there are a lot of places where if you want to take one functionality, we just introduce an if flag. So if the flag is on, then you do this, otherwise you don't do this, right? So instead of that, you should think in terms of introducing like strategy pattern, right? Because like the more the if loops, the more the cyclomatic complexity increases. So don't do those kinds of if loops, flag based if loops. And then not to mention test first. So I mean, again, this is also a beaten topic, right? So there are various blogs, videos, and courses on test-driven development, right? So it's a new dimension to the way of working, the way of thinking. It helps in the moment you start writing tests first, the way you think about it, the single responsibility principle, what Arif was talking about, right? All of this falls in place. So if you go the other way, if you write code and then you write test for that, the chances that you are doing more than one thing in that function and you don't realize it, right? But when you're doing TDD, those things come out pretty evidently.
Alright, let's try to now see how we can support actually two different type of data source for the same app. But before jumping into how we did it, let's try to see what is the general public opinion, what usually a developer would do if the same situation given to them. Now what do you think about this approach? In this case, the developer has basically copy pasted the entire repository. They have created a replica. One replica is working with CloudDB, the other replica is working with on-premise DB, which means one is working with SQL, the other one is working with NoSQL. Now what do you think? What is the obvious drawback of this approach? Anyone? Synchronization, duplication, of course. Yeah. So, exactly. So we obviously see a lot of problem with this approach. Now let's try to see the other way which people may go around. Now in this case, this developer, what he has done, this developer has created a flag. Using that flag, this developer is basically trying to demonstrate which database is going to be called. Either it's going to be on-prem database or it's going to be cloud database. What do we see wrong? So what is the principle which we are violating here? Anyone? Single responsibility, of course. Now, of course, talking about the drawbacks of the those two approach, as we saw that you will have to end up maintaining the two code base and maintaining the same code base in two different places. Your code quality will go for a toss, and in future, let's say if you want to introduce another database, you will have to write a lot of piece of code, and maybe you will have to create another repository if you go with the first approach. Now, before talking about how we solved it, let's talk about what is the best way in order to solve it. And in order to solve this, the best way which someone can think of is basically dealing with abstraction. Now abstraction is something which is very common word in the software engineering. This at its core basically says, I'm going to hide all but only the related data which are necessary for my object and keep all the complexity hidden, which will increase the efficiency. As you can see from this picture, here we have, this is like the ugliness of real life. This is like you have a lot of complex code written and you put an interface on top of it which will hide the complexity. Let's try to understand this abstraction with another example also. So in this case we are going with a car example. So generally in order to understand abstraction we have many examples, but turns out this automobile is basically a very clever example in order to understand abstraction, because in this case, for example, we have a car interface where we have certain functionalities such as start, stop and all. Now the beauty of this abstraction layer is that whosoever is implementing it, so this implementation will vary from car to car. They may have their own implementation, but for the outside world, or in this case I would say for the driver, they need not to know how this inner working is basically happening, because they are working on the abstraction layer. But what happens is over time these abstractions starts to leak. So when you have your complexity has increased, when you have more and more complexity increasing, in those cases these abstractions starts to leak. For example, suppose for whatever reason there is a problem in your car. Now in order to fix that problem you of course need a mechanic, but in our case if you look at our car interface which we showed just before the previous slide, so there we don't have enough information to understand actually how the inner workings of the car is actually happening. So in that case, if at all you want to solve this problem, you will bring in the inner workings of this car model inside your interface, and that will obviously increase the complexity. And of course it will give the chance of the whosoever are the consumer of this interface to get into some accidental breakouts or something. Talking about this abstraction in a programming example, so how many Java developers are here? Okay, we have a few. So in Java we have this Hibernate concept where using ORM, which is object relational mapping, we can write any query. So it's like instead of writing a native query, ORM has provided us an abstraction layer where we can write these SQL queries. So suppose you can write something like find by ID, which will later be translated into a SQL query. But what happens is over time, when you want to write a very complex query, where maybe let's say you have a lot of join, a lot of condition, in those cases you may find that this ORM is not basically giving you the performance which you are looking for, and in that case you may want to go back to the native query, and this is something where abstraction basically leaks out. Another example will be like you may have a query that find by name. Now in this case, when this method argument receives the name, we have no idea whether we are talking about case insensitive or non-case insensitive unless you go into the details to see what it actually does. Alright, now enough on the abstraction. So of course we were talking about abstraction, and that is something what we used in order to solve this problem from our side. Let's try to see how we actually solved it. So of course we created an abstraction layer. Let's say we had a person repository. This was the abstracted layer with which our business logic was using, and this abstract layer is being implemented in two ways, one for the NoSQL, one for the SQL, and they both have their different implementation, and based on that it will save the data into the respective DB. As I said, our business logic had nothing to do with any specific database. There was no reference of SQL or NoSQL. It was working on top of an abstract layer, so there was no change required in our business logic layer. And this is an example of our entity. As I said, the same model we have used for SQL and NoSQL, that is like code reusability. Now how we are able to do it, because when we create a model in Java, we wanted to specify that this model is going to work as an entity for the SQL as well as NoSQL, and in that case this is how something you can use like JavaX for SQL and data store for NoSQL. So what we can conclude based on this, the key here is basically to avoid leaky abstraction, and whenever you have a new requirement or whenever you want to add any new functionality, so instead of going into the same place and adding more and more complexity, it's better that you add a new abstraction layer. What it will do, it will basically not make your code very complex, so that in future if you have to add any other functionality, you can easily accommodate it. Similarly, we should also think of removing the complexity, because when your complexity increases and if you are trying to increase more and more abstract layer, there's a high chance that your abstraction will leak out. So in those cases we may actually need to go and see our solution architect and see how we can remove this complexity, or if there is a simple way to do it. Now enough on how we did and what we followed to do it. Let's see that all this, whatever we did, this clean code practices and everything, did it actually help business? So we were able to go live with this approach 3 months ahead of the original schedule. 3 months is a very long time. This is something which you don't get to hear in software industry very often, because think about the amount of time we saved. It's not just the development time, it's about the QA time, the amount of time someone would go to see the bugs, everything. For like 3 months we were able to save, and since we were able to use the same piece of code, there were less regression, or we can say there was almost zero to none regression issues, since all the code was reused.
Thanks, Arif. So I think, I mean, not only applies to database, right? I think today, I think we are in microservices. Most of us are moving towards microservices. So there is integration points to a lot of things, right? So database is one such integration point, that you would be using a cache, right? Or you would be using a messaging system, or you would be using another microservice. You're connecting to another microservices, or you would be connecting to a third-party, application, right? So wherever there is integration points, wherever there is like coupling with other system, try to introduce abstraction layer. People call it anti-corruption layers as well, right? So this prevents us from protecting our business logic to not be modified, right? So so that's what Arif has been saying. So let's see how we did this. I think the team was pretty mid to large size teams, right? So we are looking at 8 developers, and how we achieve this clean code is, right, like as I said, like federated governance, right? So we keep a checklist, right? And we had a lot of gatekeeping. So when I say gatekeeping, we built these checks at the compile static analysis tools. For example, if a developer checks in, the build will fail if a method is having more than, like, say 20 lines, right? So the method, I mean the build will fail if the test coverage is lower, right? The build will fail if there are more than 3 lines of duplication in the code, right, across the project, right? So we built all this into the build pipeline so that we ensure that as much as possible we can kind of automate it. And then of course there will be places where we will not be able to automate. There we used checklists, we used nudges. So when I say nudges, we had this concept of mob reviews. So what happens is every day post our stand up, right? We time box 10-15 minutes to look at any piece of code, right? The developer is free to show the code that he has written the last 1 or 2 days and ask for feedback with the team, right? So mob review and peer review are kind of same, but the advantage with mob review is that the feedback that is shared goes to everybody in the team, right? With peer review, it usually goes to the developer who actually did the work, right? So mob review helped in that way, and we time boxed it to 10 to 15 minutes every day. Anybody can show any code. It need not be a completed code, completed feature. It can be like, I'm starting to do this, I'm heading in this direction, right? I introduced this kind of a design. So that gives a very fast feedback, like, team can look at it and say, hey, this is wrong, right? Hey, this looks, you're doing more than one thing in this class. So all those quick feedback comes in the mob review. So we also have peer reviews. So there is code cops. Again, pair programming was best place for that, right? It's a continuous review cycle. So the moment a developer is coding, the other pair continuously reviews and gives feedback, and they rotate, right? So pair programming was introduced for that sake. Yes, and every developer, right? I think every developer will have to look at it like you have to take an oath, right? Like what it says here: always leave the campsite cleaner than you found it, right? And if you have that rule, if every developer in the team has that rule in mind, right? I think we will eventually build cleaner code which is more evolvable, right? This is a very interesting topic, goals versus systems, right? So here what we did was, I'm talking about, when I say system, we're talking about routines, right? For example, if I'm a developer, what are some developer habits I should build? Like, for example, it could be like before you start the day, you look at the commit log, right? Like how many people have checked in, what is that they have committed, what is the new thing that they have used or tried, right? It could be like building a CI pipeline which fails, like as I gave an example, which fails if there is any violation, right? If a class is more than 150 lines of code, fail it, or more than 100 lines of code, fail it, right? If the method is like more than 15 lines of code, fail it, right? Build routines. And also like the mob reviews, again it is a kind of a routine. So if you feel that, okay, I don't have time to do it daily, maybe do it 3 times a week, right? Versus goals. So goals, when I say, it's more like your sprint goals, your velocity or your iteration goals, right? It's okay, like don't be too much worried about not meeting that goal, but if you have systems and routines and habits in place, it will eventually ensure that your goals are kind of you're going towards that goals. Okay, so what we're saying is like the message we want to convey is like be at heart, right? Like be an engineer, right? To focus on building things which is right, instead of getting the output or moving faster, right? Think of building it right from day one. With that mindset, I think we will be able to build evolvable, maintainable code base. Yeah, this is one thing that we keep hearing, right? The number one reason why it's very difficult to maintain clean code is that we give an excuse like we'll do it later, but later never happens, right? So I think the message is, I think from day one, focus on habits, developer routines, and make other developers also on similar lines, right? So that once you build, don't always be a rock star on the team. There should not be any rock stars within the team. The team should be replaceable, right? So we have to have those things in mind, and we have to convey the whole thing to the developer team. So in that way, whoever comes in and codes, they all follow the same kind of checklist. They follow the same patterns. So that's the routine I was talking about. So build routines within the team. So with that, I think we close on this topic.